Hi everybody, welcome back to the TETRIX RoboBench video series. This is Tim, and today I have with me my colleague Ray, and we're going to talk to you about getting started with ArduBlock. Now, in the past we've mentioned as a programming option with TETRIX Prime the ability to use an Arduino and our proprietary motor shield. And Ray has been involved with writing the STEM curriculum for our TETRIX Prime. There's 9 weeks total of that, right?
Yes.
And 2 of the units are involved using the Arduino motor, the motor shield and the Arduino control board. And we're going to go ahead and go into a little bit more of that with how that works with the ArduBlock software program. But we're going to start, Ray, I think, by looking at the hardware, right?
Right.
So we're going to turn this up, and hopefully you guys can see a little bit. And Ray, if you want to kind of go ahead and take over and explain some of the things, I'll chime in as I see fit, okay?
Okay. We have our Pittsco proprietary shield on top, mounted on top of an Arduino board here. And probably the first thing you'll notice is the red and green buttons.
Okay.
The red is a reset button.
Okay.
And it's just like the reset button down here on the Arduino board, and it functions anytime you push the red button.
Just acts as a natural reset, right?
Natural reset.
Okay.
The green button, which you think would be there to start the program, is actually non-functional until it's programmed.
Okay. So it just serves as a digital input until we program it to do something, right?
Until we program it to do something.
Okay.
It's attached to pin 7.
Okay.
Digital pin 7. And so when we start to run a program, we have to write that in to tell it to listen to port 7.
Okay.
And so we can push that. Along here are connections for Grove's sensors and input devices. The row toward the center here, all 3 of those are digital input ports.
Okay.
And those are there. The line finder sensor plugs in there. The ultrasonic sensor, we can plug an LED in there. So we can put 2 or 3. We can put 3 of those, 3 digital sensors.
Any digital input.
Any digital input or output.
Okay.
Goes on there. Then the second row here, there are 2 ports for analog sensors.
Okay.
And there is one for an I2C connector. Now we don't use those right now, but they are available, so that if you want to do something more advanced, or at a later date when we come up with new products, we'll probably use those.
Okay.
So there's some different inputs for there. Down the center of this, there is a connection. When this is hooked up to USB, it's powered through the Arduino.
Okay.
But there's not enough power to run a servo motor or other devices. So we attach a battery connection.
Supplemental power.
To add power.
Okay.
Now, the black wire on this connector, there's a little line along the board right here, and that black wire needs to be on next to that line. There's a line there that says battery. Then the servos, these pins here, 8 through 13, are servo pin attachments.
Okay, 6 servos, right?
So we can put up to 6 on there.
Okay.
And the black wire from those have to be in the same row as the black wire
like the power
from the battery. Just like the power. So that's the way. Now the Arduino then.
We also have 2 LEDs, right?
We have 2 LEDs.
Just don't want to forget the LEDs because we're going to use those in just a minute.
We're going to turn that. Maybe they can see those. There are 2 little LEDs right in here.
Okay.
And they're attached to pin 2 and pin 3. Now those are on the board, just monitoring type LEDs. We can use those to monitor them. If we want to, we can plug in a remote LED. Okay. And it plugs in to one of the digital ports over here for an output.
Right. Last but not least, we have a power switch, right? So we can actually control that external power. Okay.
Turn the power on to the board. Now it's getting its power through this battery.
Gotcha.
And that will also power the Arduino board underneath.
Okay.
Now we can also plug that into a USB port.
Okay.
From our computer. And if we turn the power off, you notice our board, our shield.
Right. Expansion shield.
Our expansion shield, the light goes out there, but the Arduino itself is actually powered up.
Gotcha, because it's connected to the computer.
If I open this up, again, when the computer comes on, it will power this board down here.
Okay. So that's a pretty good overview of the actual hardware. Again, we're talking about, we've got this motor shield that Pittsco has made. It's an expansion shield that goes onto an Arduino. And we've got clips that whole thing just mounts onto a Prime robot, right?
Yes.
Okay. So once we've got the hardware, the next thing we have to add to that is software, right?
Right.
So we're going to go ahead and we're going to open up our computer and look at the ArduBlock software. Now, this is an add-on to our standard Arduino IDE, and we're going to pull it up here in a minute. And we've got be able to capture our screen, so you're going to be able to see, hopefully, as we go through this software, what some of our mouse clicks and everything looks like. Okay, Ray, so let's go ahead and look at our software. First thing we need to do is obviously launch Arduino, right?
We launch Arduino, and as soon as we get the software up, it comes up, then one of the first things we should do is go to the tools on top menu bar.
Okay.
Click Tools, and go down to Port.
Okay.
And over here in this Port section where the window pops out, you should see one that says Arduino Uno.
Okay. That's if we have it connected, right?
If we have it connected. If we don't have it connected, it won't show up.
Okay.
So we're going to click that and select it. So now when we look at that port, there's a check mark beside it.
Okay.
And that shows us that we're connected to an Arduino Uno board.
Gotcha.
Okay?
Makes sense.
Our next step is to, again, back at the tools, click on ArduBlock, and the ArduBlock window will pop up.
Okay, so now we're actually in the user interface that's mainly focused in graphics, and it's called ArduBlock, right?
Yes.
Okay.
It's a plug-in that fits inside of the Arduino.
Okay.
It allows us to drag blocks and do programming without having to worry about having braces in the right spot, extra spaces, semicolons.
Text syntax.
Syntax based.
Okay. So kind of walk me through the interface here, Ray, and show me some of the different aspects of it, and so just what everyone would kind of really need to know right off the top.
Okay, so right across the top we've got some toolbars,
Gotcha.
New and save as and open. Along the left side we have some containers.
Okay.
And inside the containers are the blocks that you're actually going to use.
These are the graphic programming blocks that we'll pull over and use.
Yes.
Okay.
Now, every program must have a loop or a program block.
Okay.
If it doesn't have those, if those blocks aren't there, you're going to get an error message.
So show me how that you would put one of those in your program.
So if I want to pull one in there, I just click on it, drag it over there, and drop it in place. Now, you can't have two.
Okay.
So now I have two loop blocks because inside the program there's a little loop block.
Right.
So I need to get rid of one of them.
Okay.
So what I'm going to do is just drag this one over to the side. When you drag it back over, it doesn't matter which container. If you just drag it off the screen to the left, then it disappears.
Gotcha. Now up over here in the right-hand side, you've got a little mini map, right? That kind of shows you a large overview of what you've got in your programming area.
If our program gets too large,
yeah,
we can use the scroll bars on the side to move that around. You see the red block moves around, and we've got a scroll bar at the bottom.
Okay.
So we have a large window to work from, but we're only looking at a very small portion of it.
Gotcha. Gotcha. Makes sense.
Okay.
So what are some of the other tabs on this left side?
So underneath control, we have the loop in the program.
Okay.
We have an if block, an if then else block, while block, do while, repeat.
Some of the basic programming nomenclature that normally you would recognize.
You would see.
Okay.
Okay. And under pins, we have digital pins and analog pins.
Now these are referencing the actual hardware itself,
yes.
right? Okay.
Those refer right back to the hardware. We have blocks to set those pins. We have a servo block, 360 rotation motor block, which our servos with Prime, we always use a servo block.
And that'll address both the standard servo and our continuous rotation servos.
It'll make both those. We have some other features down here. that we can use. We don't really use them that much. There's some test statements, greater than, less than, those kinds of things. Again, you're programming.
Okay.
We have math operators.
Okay.
So if we have values that we want to use, a nice one here is variables.
Okay.
So now we can set variables, an integer variables, digital variables. We have high and low, so we can turn switches on and off.
Okay. So we've got just a full array of all of the programming functions in the graphic format, right?
Yes.
And easy to use plug-in type graphic pieces that pull over.
And they're all keyed, so you can't put them in the wrong place.
Okay.
We have Seed Studio Grove parts.
And those are the sensors that
Grove
we send
sensors that we use.
Okay.
And so there's a wide variety of those that are available.
Okay.
And we don't use several of those. We don't use, but they are available. We also have in our autonomous unit, we use an ultrasonic sensor that comes from the Grove ad down here.
And there's either other options
Then
there
there are other
if
options
you want to
if
do
you
something on your own.
Yes.
Okay. What about this one that's a generic hardware?
Okay. The generic hardware has a delay in it.
Okay.
Those are the two that are important in there. These are generic blocks that should work with, if you don't have the devices from these companies over here, then they're just a generic device. You can use those to put in over there.
Okay. Well, let's do something.
That's communication.
Oh, okay.
There's a communication one we need to look
Okay.
at. So if we want to get a reading off of a meter, ultrasonic sensor, for instance, we want to know the distance that it's actually showing. We can go to communication, and we can use the blocks here and create a way so that we can read
Get information back.
And even though we don't have a display on our Arduino,
right?
We can while we're hooked up to the computer, we can get a reading.
Okay, that sounds like that would be important.
So those are important things to do.
So let's do something. You can tell I'm kind of anxious to get going here. Let's go ahead and write. What's the beginning program that we might do in this format? I know in a lot of programming there's something called a hello world.
Okay.
So what's the equivalent
we have
here?
The hello world equivalent here is to blink a light.
Okay, so let's blink a light.
So let's see if we can blink a light. So we're going to while we're there, let's also program that start button.
Okay.
So we're going to use the program block.
Okay.
And we're going to use a while block. Now, in a program block, there's a setup section and a loop section.
Okay.
Setup section runs one time.
Okay, so that's kind of like an initialization, and it goes through that one time, right?
One time. And then it goes to the loop process and does everything there. So we get a while block, and we put it in while, and that just snaps in place. Okay, so we're gonna check a digital pin. Okay. So we bring the digital pin block out here, plug it in, and it comes in with default with a 1.
Okay.
We click on that number and change that to 7.
Because the green button is at address 7.
Address 7.
Okay. So let's go ahead and we're going to create blinker lights, right?
Right. So now we've got a while block in place.
Okay.
We've got a digital pin 7, so that's going to turn on enable our green button to start. So now we're going to come over here and set another digital pin.
Okay.
And put it in the loop place. And we're going to set this to pin number 3.
Okay.
Which is on the board.
Okay.
A green LED.
Okay.
And we're going to set it to high.
Okay. So basically, we're turning that light on.
Which turns it on.
Okay.
Okay. And we're going to go into the generic hardware and get a delay. And we're going to put that in.
Okay.
So for 1 second or 1,000 milliseconds, which is 1 second, we can click that and change it to a different number if we want to. So we're going to leave it for 1 second right now. And then that's going to turn our LED on.
Okay.
So if we want it to blink,
right,
we're going to have to turn it off.
Right.
Because the Arduino doesn't know what to do. It's going to turn on and stay on. So we're going to clone this, which lets us copy that, move it down and plug it in.
A little bit of a shortcut there.
A little bit of a shortcut. But now we're going to switch it from high to low.
Okay.
So now if we look at the logic of our program, the while block, it's going to set and wait until pin 7 is pressed.
Okay. That's going to be our start command because it's going to just stay up here until that green button's pressed, right?
Correct. Then it's going to move into the loop section of our program.
Right.
It's going to turn the pin 3 to high for 1,000 milliseconds or 1 second.
Okay.
Then it's going to set the digital pin 3, the same pin, to low, which turns it off. It's going to go off for 1,000 milliseconds, and
then go right back up to the top,
right back up to this, not back to the setup, because that's just a one-time run. It's going to stay within that loop, and it's going to go back and turn it on for a second. And so now to get that into Arduino, we click Upload to Arduino, and we'll have to save it. And we get our file saved here. And now we can see the syntax code.
Gotcha. Then this is the actual code that would be in text. If you did the same thing in text, this would be the equivalent, right?
Yes.
Okay. So while you do that, I'm going to go ahead and I'm going to press the green button on our board.
Okay, it gives us a message.
Oh, okay.
It says done uploading.
Gotcha.
So now we should be ready to go.
If I press that, oh, I've got a green light that is flashing. We have success.
On and off.
Now, if I just let that go and I press the red button, what's going to happen?
It should stop.
Okay, so let's try that and see. Yep, it stopped. Now,
nothing will happen until you hit that green button.
So it's continually doing that whole program as a loop, right? Because this is a solid state machine. Once we load a program on it, it is loaded, right?
Correct.
And so if I go back and I press the green button again, since we haven't changed our program, it's going to run the same thing, and I've got a green light flashing, right?
Flashing green light. Now we can play with that a little bit, and we can change our value to 2,000 milliseconds. Okay, and then we're going to re-upload that.
Okay.
And it's done uploading.
Okay, so now when I press my green button,
now we should see something different.
I've got a longer duration, but still the same off period.
Same off period.
So you can create a varying pattern of flashing lights just by changing that delay, right?
You can.
Awesome. So we've made our first program. We're programmers, Ray.
We made a program.
Awesome. So it's kind of cool that we were able to turn on a light and think, but what if we want to make it move? We like to make things move, Ray. So what would we do if we wanted to make something move?
Let's just take all this out.
Okay.
And we're going to go into pins, and a servo gets us to move.
Okay.
Now, our servos can be attached to pins 8 through 13.
Okay.
So our robot is built.
Right.
So
looks like I've got a servo in number 8 and number 9.
Okay, let's just move one.
Okay.
So we're going to go to we're going to go to the servo, and we're going to set that to pin 8.
Okay.
Now, a continuous rotation servo will run from 0 to 180.
Okay.
And 90 is stop.
It's because that's the midpoint, right?
It's the midpoint.
Okay.
Now, not every servo will stop at 90. Sometimes you have to fudge that number a little bit.
Because there's some differences from the factory.
Because of the factory.
Right.
And 0 will cause it to rotate in one direction. 180 will make it run in an opposite direction.
That's for continuous rotation servos. Okay.
Okay. So if we set it like that, and then let's put a delay in there again.
So again, we're creating a duration, right? We're telling the motor to turn on, but we need to create some kind of duration.
We need to tell it how long to run. So we're going to tell it well, we better go back because we don't want this to be stopped.
Okay.
So let's make it run.
Okay.
So we're going to make it run full speed in one direction, and then we're going to stop.
Okay.
And we're going to clone that.
Okay.
And then let's bring it down.
Okay.
And now let's have it stop.
Okay. So now we've got, we're telling our motor to turn on in a certain direction.
Turn on, move in this direction, 0, for 1 second.
Okay.
Then stop for 1 second, and then it will go back and move again.
Only after I have...
Only after you push the green button.
Okay.
So let's upload that. Okay, it's done.
So I'm not moving now
Okay,
because I haven't pressed the green button.
no green button, so we
So I'm
haven't
gonna-
started.
I'm going to press my green button. And, you know what I need to do, right? I need to turn power on to my board. Because I didn't have my board
You didn't
motor
have your
shift
board.
power. So I've got a motor. It's moving in a certain direction. And I'm getting a little bit of a pulse, Ray. So it doesn't seem like 90's a full
90's
stop for
not
that.
a full stop.
So let me abort that.
Okay, let's try 95. We don't know which way we need to go with that. So let's just try that and see.
I think you got the right direction. Let's see here.
Well, we haven't run it yet, so it's not been set. We could put a stop in the setup and make it stop to begin with.
Okay, I think that worked, Ray, because the motor is definitely stopping. So if I wanted to put a stop in the setup, how would I do that?
We'll just clone that stop.
Now, would you put it below that or above that? So, while the digital pin.
We probably ought to put it above it.
Okay, because we want that to be the very first thing it does,
Very
right?
first thing it does. Okay, let's see if we get that solved.
And it's done uploading, and you know what? My motor's not
The
moving.
motor's not moving. Nope, no movement whatsoever.
So now when I press my green button, it should begin to move, right?
Correct.
It's doing that, and I'm getting an actual delay on and off, which is what we expected to do,
That's what we
right?
expected to do.
So obviously for this particular servo, you had to go ahead and change that 90, that default condition to a little bit more than 90 to get it to
To
actually
get it to
stop.
actually stop.
So let's
Make it go the other way.
okay.
So now we cloned a block.
Okay.
Now we're telling it to turn in one direction,
Okay.
stop for a second, turn the opposite direction,
And wait, and then go back and do the.
and wait and run for a second, and then we probably should stop it again, so we don't have our servo jerking back and forth. So we're going to put that back at 95.
So now, if I kind of predict what should happen here, is I should have a wheel that actually starts and doesn't move until we press the green button,
Correct.
and then it's going to go full speed in one direction for a second, stop for a second, full speed in the opposite direction for a second, stop for a second, and then go back and forth, right?
Yes.
So let's upload it and see what happens. I'm done uploading, so I'm going to try this and see what happens. I think we've got success, right? It's doing what we expect
Doing
it to
what
do.
we expect.
So let's talk about the software just for a minute, because one of the cool things I think about this software, Ray, is the fact that I'm working in a graphic environment. I'm actually seeing the blocks that make visual sense to me, but I'm actually getting also the equivalent in a text format. So I'm actually getting a little bit of comfort level or familiarity with that syntax type program. What would happen if I made changes in the text program only? Can I do that?
If we go in here
Mm-hmm.
and highlight this 1000,
Right?
change that to 2000, and upload that.
So now I'm beginning to be able to make some
Let's see.
changes.
I think we click right here.
Yeah.
Upload right here. So we can now actually change in the syntax based side.
Yep, I see it's now it's going a longer duration in the one direction. So I'm able to now transfer the knowledge from that visual environment into the text-driven language, right?
Yes.
That's the power of this particular software. Now, one of the things I want to point out too is, and correct me if I'm wrong, but we could actually unplug the unit. With this particular software, the program is downloaded to the target, to the Arduino,
Yes.
and it stays on that Arduino even though I might physically unplug it, right?
If you unplug that USB cable, it's on there stored, and you should be able to
Cool.
push your green button and make it go.
Because there are some softwares that out there that will allow you to program to Arduino, but you have to maintain a connection, right? Okay, so that's a cool
This
thing
one
about
lets us
that.
disconnect.
So let's take that to the next step. Because we made one wheel move, what would it take to actually make both wheels move together and make our robot physically move in one direction or another?
It's simple addition of servos.
Okay.
So we'll pick up another pin, drag another servo over here, drop it in.
So now we're talking
Now-
to two motors at one time.
Now where your other one was plugged into 9,
Uh-huh.
and because the position of the servos are opposite,
Okay.
instead of putting in 0, we're going to have to put in 180
Because I've got two motors
Because they're-
in back to back.
back to back.
So then for them to work together, they need to go in opposite directions, right?
Correct.
Now, how about up here at the top? If we want to make sure that both motors stop at the beginning, we probably ought to add one up there,
We
right?
probably ought to add a servo up here
Okay.
and set it to pin 9. And we'll start with 90.
Okay, because we're not for sure, we haven't run this servo before, so we don't know if 90 is the actual stop point for this.
Right.
But we're going to try it there and see, right?
So we're going to start with 90.
Okay.
And because we moved it, let's take away some of these down here. Now it's real easy. If we take it out of the block,
Out of the loop.
it's outside that loop. This part of the program will not run.
Okay. That's good to know.
It's only going to do this part over here. So we'll upload that.
Oh, you know what?
We've got a little.
I've got a little creep on that one
Got a
wheel,
little
so
creep.
obviously 90 is not where we need that to be,
let's
right?
try 95. Just try it.
Done uploading. You know, my motor's not moving, so I
Motor's-
think that did it.
That did it.
So now what should happen? Because we've just doing this for, we're turning the motors on in one direction. We've got a delay in there, but we don't have anything after that. So what should I expect this to do, Ray?
By going through our series here, one should run full speed one direction, one full speed in the opposite direction for 1 second.
Okay, let's see what happens.
And then it's going to repeat, so it's going to wind up being a continuous movement.
Gotcha. And that's what's happening. Now, I'm actually, depending on which is the front or the back, I might be particularly moving backwards, or I might be moving forward, but
Correct.
that's depending on whether
Depending on which way
I've
which
decided
servo
it's
you
front or
have.
back.
Right.
Okay,
And which servo you have, you may have to switch places with your cables
gotcha.
or change your numbers on your ArduBlock.
So I can stop that. And so now, Ray, basically, if we have the basic movement now, I could add things. I could make it stop. I could make it turn. Because now manipulating those numbers, it's just a matter of manipulating those and telling the
Just a
motors
matter
to do
of
different
dropping the
things.
servos in and the delays and telling it which way to go.
Gotcha.
If you want to make a right turn, make a left wheel stop and a right wheel stop. Left one keeps going.
So I've got the basics that I should be able to start playing now and make my robot do all kinds of things,
Make
right?
it go.
Now that we've got that in place and we were able to actually move our robot, we've got some things, ammunition to play with and different things to try to make our robot do different things. So that's a good starting point for you. Hopefully you'll have fun with that. Remember, go out there, build some robots, have some fun, and come back and see us.